Okay, everything just crashed, but I think I got it all back working here. So let's see, I divided both sides through by 3 pi r squared and canceled the 3 pi r squared. And so I get x equals this. I'll put a box around it. That's my substitution equation. I'll plug that back in for x up here. When we do that, what are we going to get? If I plug that back in for x, I'm going to get c equals, I'll simplify this, so that's going to be 2k pi r times x, which is all this stuff, plus 8k pi r squared. Okay, good. And we need a domain for this, don't we? Okay, so our domain, we've got, think about what's going to happen with this thing. As r is our variable, that we're differentiating with respect to, as r increases, x decreases, and vice versa. So what's the smallest r could be? As r shrinks, x grows. But look at the expression for x. We have an r on the bottom, and so we can't, r can't go to 0. If r goes to 0, as r approaches 0 from the right, small positive values, x approaches infinity, which is, we can see that would happen. If we have a fixed volume and the radius shrinks to 0, well, this thing's going to have to get infinitely long to hold that fixed volume. And so we can't have 0. We can approach 0, but we can't get there. What's the upper limit going to be? The upper limit is going to be, as r gets bigger and bigger, x gets smaller and smaller. And we can see down here that x would go to 0 when the numerator of this fraction was 0. So we would set the numerator equal to 0 to find the biggest that r could be, which would be when x went to 0. And we, by the way, we can see that on our shape up here too. If x goes to 0, then that just means that all of the volume, this cylinder effectively disappears, and these two hemispherical ends just come together to form a big sphere. Okay, what would the radius of that sphere be? That's what we're finding. So we get 4 pi r cubed equals 12,000. And so if we divide each side through by 4 pi, by 4 pi, we get r cubed equals 3,000 over pi. So r would equal the cube root of 3,000 over pi, which is roughly 9.85. Okay, and so that's the upper limit for r. Okay, so we could simplify this a little bit. If I were to, I don't know, I have 2 pi's there, don't I? Cancel one of those out. When I distribute this 2 pi r, some things happen. The pi's cancel. I could cancel one of these r's, and so I end up getting my function here, c of r equals 24,000 over 6, or 24,000 over 3r minus 8 pi. And then here I could cancel. I've got r cubed over r, so I could reduce that to an r squared over 3 plus 8. Oh, you know what that was supposed to be? That pi was supposed to be a k, wasn't it? Yeah, it was. Yeah, I wrote it as a pi, but it's supposed to be a k, so we got to include that. Let's put that back in there. So that's giving me 24,000 k over 3r minus 8 pi k r squared over 3 plus 8k pi r squared. And I could combine those terms, couldn't I? That's going to give me, if I combine those, that's like 8/3 times pi k r squared plus 24/3. That's a negative one too. So negative 8/3 times this expression plus positive 24/3. So I'm going to get a 16/3 k pi r squared when I combine those. Okay, let's go to the next page and do the calculus on this. Oops. Oh my gosh, what did I do? There we go. Just do that. Okay, good enough. All right, there's our function. So let's differentiate. So this is like some constant times r to the minus 1. So I'm going to get a negative derivative out of this one. Let's go ahead and differentiate this term first because we're going to get a positive term here. So that's going to give us, bring the 2 down, I'm going to get 32 k pi over 3 times r. And then this one, I've got this constant, 24,000 k over 3 times r to the minus 1. So if when I differentiate r to the minus 1, it gives me a negative r to the minus 2. So I'm going to get 24,000 k over 3, and then I've got an r to the minus 2, so I've got an r squared on the bottom. Okay, there's our first derivative. Let's go ahead and solve for our critical number then. So C prime equals 0 when these two terms are equal. So when 32 k pi r over 3 equals 24,000 K. No pi in that one, is that right? Did I do that wrong? Let's double check something. Oh, the pi's canceled, that's right. Okay, no, we're good. 24,000 K over 3 R squared. So I could do a couple things. I could cancel the 3's, can cancel the K's. I could divide each by 32. 32's got to go into that. What's that going to be? I don't want to think about that. $24,000 divided by 32 equals, yep, 750. So we can do that. And so we end up then with, what's that going to be? Pi r equals 750 over r squared. So we could cross multiply here and we end up with pi r squared equals 7, or pi r cubed equals 750. So r cubed equals 750 over pi. So r equals the cube root of 750 over pi. So what is that? We'll find out. So that's about 6.2, roughly. So that's our one critical number that is in our domain. Let's take a second derivative really quickly here. It's pretty easy to do. And we get, the r goes away, so we just get a 32 k pi over 3 minus, this is going to be a plus, isn't it? Because I've got a constant times r to the minus 2. So the derivative of r to the minus 2 is minus 2 r to the minus 3. So I'm going to get a plus, and it doesn't even matter. I'm getting plus some number divided by r squared. For any positive value of r, that's going to be positive, right? No matter what, I know I've got two positive terms here. So when I make my table, my domain was 0 up to roughly 9.85. I had one critical number, which was approximately 6.2. It was a 0 of the first derivative. We got a positive second derivative. And so this is a minimum. Found a minimum for cost when the radius is 6.2. So I think they wanted the dimensions probably. Find the dimensions that will minimize cost. We got to go back to our boxed equation for x. And if I plug in 6.2, we could even plug in the exact value. Cube root of 3,000 over pi. What am I going to get? Let's see. Okay, so yeah, we were plugging in I just did this in Desmos. So we were plugging in our minimum, the R that produced our minimum cost, which was the cube root of 750 over pi, roughly 6.2. When I plug that into our function for x, plug that value in, Desmos tells me that's about 24.8. And what are our units here? I think, what are we talking? Feet. Okay, so our dimensions would then be roughly R is approximately equal to 6.2 feet and X is approximately equal to 24.8 feet. There are the dimensions that minimize the cost of this thing. All right, I'm done.